In this video, we're going to talk about 3x3 systems of equations and something called back substitution. Now, up until this point, we've been solving systems of equations that have two equations and two unknowns, right? Two variables, x and y. But as you can see in this system that I've drawn here, we have a 3x3 system. We have three equations and three unknowns, x, y, and z. In fact, you can imagine higher systems of equations where you have four equations maybe and four unknowns, let's say w, x, y, and z. Okay, and the big question is though, how could we solve a system of equations like this that I've drawn here? Okay, in fact, maybe if you want to pause the video and kind of stare at this for a minute and try to think, how would I solve this? How would I find the x value, the y value, and the z value that make this true? Okay, well, we're not going to actually talk about how to solve that in this video. We'll do that in the next couple of videos, but I want to talk about how you would solve a simpler one than that one. Okay, here's a much simpler 3x3 system. We still have three equations and three variables, but we're going to solve it with back substitution. Now, why is this simpler? Well, notice the second equation is missing the x term, right? There's no x's. It's really 0x. And the third equation has no x's or y's. So how could we find the x, y, and z that make this work? Well, this is much simpler. In fact, we can just look at this third equation here. We have 5z is equal to 20, so we can first solve for z. Okay, and what we get is 5z is equal to 20, so z is equal to 4. Okay, the next thing we can do is take that value, z equals 4, that we found and plug it in to the second equation. We have y plus 3z equals 13, but we know what z is. So this time we're going to solve for y. We're substituting back into that second equation. Okay, that's why this method is called back substitution. Okay, we have y plus 3z is 13, so y plus 3 times 4 is 13. That gives us that y plus 12 is 13, so y is equal to 1. Okay, we found z is 4 and y is 1. How do we find x? Well, again, we substitute back into the first equation. We have our z value and our y value. Now we try to solve for x. Okay, so we have x minus 4y plus 7z is equal to 26. We have x minus 4 times 1, because that's what y is, plus 7 times 4, because that's what z is, equals 26. So you have x minus 4 plus 28 is equal to 26. So you have really x plus 24 is equal to 26, right? Minus 4 plus 28 is 24. And so x ends up being 2. Okay, so we could write our solution now as an ordered, well, it wouldn't be an ordered pair, it'd be what's called an ordered triple. Okay, or an ordered three-tuple, it's sometimes called. 2, 1, 4. 2 is the x value, 1 is the y value, and 4 is the z value. So this is called back substitution. And let me just mention that the way we're going to eventually solve a more complicated system like this is by using back substitution. But what we first have to do is manipulate the system to get rid of the x here and to get rid of the x and the y in the third equation. Okay, and that's what we'll be talking about in the next couple of videos.